This is Tim Odom of Engine Pro. We're here at the HPX show in Charlotte, North Carolina, and I've got Chris Straub of Straub Technologies, good friend and neighbor. Today we're going to talk about the changes in terms of valve train systems that have occurred. You know, when Chris and I first met,
1996.
Yeah, a while back. When we first met, the valve trains, the engine blocks, I mean, we were talking about cast iron blocks, cast iron cylinder heads. We were trying to take small block Chevrolet and big block Chevrolets and putting them big old valve springs in them. That's the way you equipped an engine to build more power. Now we're dealing with things like LTs, LSs, coyote engines, aluminum blocks, aluminum heads, and of course fuel injection. Everything has changed. So let's start with valve springs, Chris. I mean, you're a valve train expert. How has that changed as we moved into this new dynamic?
Well, I appreciate the expert, but I'm far from an expert. I've had a lot of good mentors over the years, and I did what the man above designed us to do. I listened twice as much as I talked then. So I thought it strange. I was probably in my mid-20s out of college. I was working for a company and got the pleasure of meeting a fellow by the name of Ron Proctor. Ron Proctor grew up in the steel mills of Pennsylvania and stuff, and he worked for a spring company. And back then, this was probably 95, Ron told me you always want to use the smallest diameter valve spring that you can based on the application and the spring rate that you need. So I always remember that. Well, fast forward, the LS comes into, we got Beehive, we got ovate springs. Of course, people think Beehive springs are new. I think Iski had them back in the late 70s, early 80s and stuff. So we just kind of revisited history on some of this stuff and reinvented that wheel. But the dual spring for the LSs came out, and that was an inch 290 spring. And I went back to those days with Mr. Proctor and looking at it and stuff. And of course, spintron testing was something that the cup teams had and the professional race teams, but then it kind of trickled down into the more of the sportsman type ranks and stuff. And we saw that valve train mass was a real problem. And back at one time, I mean, I think they were running like inch 700 diameter valve springs in pro stock and stuff. And I'm not quite sure, but I think we're down to inch 440, inch 500 stuff in pro stock, and the cup teams run very small stuff. So with the ability of testing and being able to run the valve trains at higher RPMs and manufacturing processes and everything else. I mean, some of us that grew up 70s and 80s in the machine shop, we can remember 3/8 stem valves coming in, and holy cow, big block Chevrolet, we're turning these things 7,500 RPM. We didn't know what the hell was going on. You were mushrooming intake valves and all kinds of stuff. Now we've got, 7mm, 8mm hollow stem stuff. It's one reason the LTs can run such higher RPMs with such low spring rates, is because it's a hollow stem valve and stuff. So we've really paid attention to that mass and the inertia, what happens with that mass when you multiply it with the RPM and stuff. So, leaps and bounds have come in there. And then cylinder head technology and stuff. I mean, you look at what it took to get 500 horse out of a 355 back in 1988, 1999. We can take a 5.3 LT motor and with a camshaft swap and do that today. But when you look at the architecture of the cylinder heads and stuff, you can go back to those days, Grumpy's pro stock head in pickup trucks. Now GM says it was a clean slate, but I can lay one of Grumpy's heads right next to an LT head, and somebody was doing some paying attention.
Well, we know that basically all these innovations in racing, whether it be Ford, Chrysler, or GM,
yes,
NASCAR racing, other racing, they have engineers committed to building those engines for maximum performance, and what they learn from there ends up on the street, thankfully.
Well, it was win on Sunday, sell on Monday.
Absolutely.
So, yeah.
So it used to be when you had a small block Chevrolet, you're going to put more horsepower in. You take that 3/8 stud out, you put in a 7/16 stud. You change the rocker arm, change the valves. In terms of valve train, besides the valve spring, how well prepared is that LS and LT and even the coyote engines and the Hemi for the valve train to run at those higher RPMs?
That's what, I mean, that's with that's what they're designed to do. I mean, they've reduced the mass of all the components, and by reducing that mass, you get much greater stability, longevity at higher RPM and stuff. I mean, simply, you know, we all need to probably remove a little mass. I know I need to remove a little mass. I'd feel better, you know. So, I mean, it's just part of it, you know. Again, it's simple give and take. But yes, the reduction of that, the larger camshafts, I mean, you know, Crane started that deal back with the larger camshaft diameters, 50 millimeter, 55 millimeter. Good friend of mine, Glenn Stiers, who's no longer with us, you know, he tells me about or he told me about the days when the 55 millimeter stuff came out and the larger cam, the cup stuff. I mean, they run over a 3-inch diameter camshaft. The camshaft housing's larger than the main shaft housing. Wow. So, I mean, and by reducing that pressure angle and getting everything smaller and tighter together, you can maintain that higher RPM with a pushrod V8. Now, the Coyote's a little different animal, right. But, you know, the Chrysler and Chevrolet stuff have to deal with those damn push rods.
Parts that we sell.
Yeah. Columns.
So, you know, people are taking LS engines and going to the salvage yard, getting one out of a pickup truck, and they're putting a turbo on them. So when you're talking about power adders on the LS in the valve train, what's the weak point?
Well, the weakest link as far as the LS and the LT platform is the crank-driven oil pump, and it's a skirted block. So that we enjoy the big block and small block Chevrolet was a cam-driven oil pump, so it ran at half the RPM. Melling has a wonderful chart on the internet that you can look up, but actually the stock pump starts to flatline at around 6,000 RPM.
Okay.
When you're dealing with an engine that you're trying to turn high RPM, you got hydraulic roller lifters. Well, there's a problem. Those 16 little lifters need oil, and when you cavitate, now you've aerated oil, and we all know what happens to a hydraulic system when it gets air in it. It's not happy. Melling has some oil pumps to get up to high RPM. I have to believe that's why GM, when they were testing the Z06 and the 427, why they went to a hybrid dry sump system, because with that 4-inch stroke crankshaft with a skirted block, you get so much windage in the block that it's going to create the aeration of the oil and stuff. So they had to get the oil out of the pan and get it away, so it had some time to rest and get rid of the air bubbles and stuff. So the weakest is that. Lake Speed's got a good video changing the oil on an LS, and it's almost 40 seconds before the top end of the engine after you've changed the oil before that crank-driven pump picks the oil system up and stuff. So if there is one weak point to the LS and the LTs, it is the oil pump. But in GM's defense in the LS and the LT, it gave us a huge resurgence for the performance industry. I mean, the LS platform really, I wouldn't say saved this industry, but it really gave us a boost in the arm. And then we had generations after. I'm a Gen Xer, so we had the generations coming up. We wouldn't even think about a turbo system back then because it was mechanical injection. Well, now we've got computers. We've got generations that understand computers and stuff. And I mean, it's kind of the truth. You find a 200,000 mile 5.3 in the junkyard and go on eBay and throw $1,500 worth of turbos for it, you can lay down 1,000 horsepower. And and you built a may pop, but nobody cares of it. It may pop, it may not. You don't care. I mean, go get another one.
But we're seeing people putting LSs in Lamborghinis and other cars that they would never have thought about putting a small block Chevrolet and cast iron block in it. But now that LS, as you said, has become a platform that is accessible to a lot of people.
I've got several friends that are avid bow fishermen, and you see a bow boat now when they're turning it into a fan boat or an airboat, it's an LS platform engine on it. Because when you can get 550 horsepower out of something that weighs 350 pounds, reliable compared to a big block Chevrolet where you're going to lay 800 pounds on the back of that boat, it's a huge difference.
I have one last question for you. You're a camshaft designer, or something you've been doing for a long time.
They say that.
Well, you've proven it. So when you're designing a camshaft for an LS, LT, those type of applications, this new ecosystem we were talking about, not at all new, but new compared to the cast iron blocks, what changed?
Well, the cylinder heads today. I mean, I've always argued and been laughed at, but I mean, I don't care. I'm pretty thick-skinned and pretty thick myself at Petite Husky. If you give something, then you have to take away something. And GM and Chrysler and Ford have given us really high-flowing cylinder heads. Well, if a head moves a lot of air quickly, that means it can fill the cylinder in a shorter amount of time. Well, what's duration on a camshaft? Time we hold the valve open, okay? So when the LS7 came out in 06, I mean, GM gave me a gift on an example, because here you got a head that flows 330, 340 out of the deal. It's 427 inches, makes 575 horsepower, and it's got a camshaft that's 209, 231 at 50. It's tiny,
right?
But it
You would
makes
never
that
thought of
kind of
that with a
power,
cast iron.
right? Exactly. So you look at modern day heads today. So when I'm looking at something, I'm looking at where the customer, what the demand is. Demand is piston speed, where that sets the demand, what has to be satisfied. The supply is the cylinder head, both in and out. And based on those two, it's mathematical equations to get to the point in the area of the camshaft.
Volumetric efficiency.
Volumetric efficiency. All my stuff is very high in volumetric efficiency. Because at the end of the day, what are we trying to make? We're trying to make cylinder pressure. Well, what does cylinder pressure make? It makes torque. Well, what does torque and RPM make? Horsepower. Everybody thinks there's a magic lift, a magic this, a magic that. I want to make as much pressure as I can, type deal. And, you know, I like short stroke, big bore combinations, because with the same amount of pressure on a larger bore, you've got more force. Well, more force creates more pressure.
More power.
More pressure. So,
No.
yeah.
All right. Well, Chris, thank you very much.
You're welcome, Tim.
So it's Chris Straub. Would you tell us, if somebody wants to reach out to you regarding camshaft design, about any questions, how can you reach you?
You can reach us at straubtechnologies.com, or you can give us a call at 423-391-7774. We're a complete automotive CNC shop. My shop foreman, Billy Fisher, Billy worked for Robert Yates, and he worked for Childress, worked for Howard's Camshafts. He's very accomplished in many segments of the industry, design cylinder heads, port development and stuff. So we do contract porting, contract cylinder head work, block work and stuff. We got a new LS LT block program. You can go. We'll put the heavy wall sleeves in it and stuff, but all that can be found at straubtechnologies.com.
Thank you, Chris.
Thank you.